All right, so for this review for week 4 quiz, remember I'm recording. So these first ones, when we want the interior angle sum, this is when we use our formula that we do n minus 2 times 180, with n being the number of sides. S that I used here is for the sum. So it's going to be important that you count carefully the number of sides. So I like to touch every single one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So for number 1, I'm doing 10 minus 2 and then times 180. So 8 times 180, 1,440 degrees. You guys agree? Yeah, good. Number 2, when you counted, how many sides did you get? 11. Yes, we have 11 sides. And I would not usually, just eyeball that, but I also got 11, and several of you have confirmed that. So then 11 minus 2, we're doing 9 times 180. So 1,620 degrees. So these are some of the angles, so they would be in degrees. And then maybe if we have only this many sides, we can just count without touching them. But here we have a pentagon. It has 5 sides. So 5 minus 2. So I have 3 times 180. 540 degrees. So far, everybody feel confident? We're good? Okay. Awesome. So the ones below this, now notice the directions. The directions say find the measure of one interior angle, or it might, maybe it says each, sometimes they said each angle. And now they have to specify that they are regular. That means that all of them, each angle is the same, every side is the same. And so we do what we did above and then divide it by the number of sides. So now we're doing n minus 2 times 180, but then we divide that by the number of sides. So in number 4, I'm going to count. Start wherever you want, but mark them so that you know you count it correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sides. Anybody else get 11? Awesome. So then 11 minus 2. So I'd have 9 times 180 and then divide by 11. So this one, notice it does say round to the nearest tenth if necessary. This does not turn out nice and pretty. When I do, you little bastard. We'll be doing 4 times 180 divided by 6. I just got a message on my screen that said, restart recording. I don't know when it stopped, so sorry, ladies. Hopefully, if you got the beginning of each of these sections, this isn't the hard part, so I'll keep a better eye on that. So 120 degrees. Also not meaning to call any male who watches this in the future a lady, just that the 2 people I know will watch currently are both female. All right, 5 sides. We actually already figured that out, right? That was 540 because 3 times 180. Because I did 5 minus 2. But then remember that you're dividing by 5. We should not get answers of 180 for these. So 108 degrees for our pentagon for each angle. Everyone still feeling confident so far? Yes? Awesome. Love it. So page 2. So before you just think that, oh, I do the same thing I did last time. Notice it says exterior angle, and it says to find only one. Now, there is more than one option here. You could find the interior angle and then subtract from 180. Or you could remember that exterior sum is always 360. So exterior sum is always 360, no matter how many sides. And then we're just doing 360 divided by the number of sides. So here I have 1, 2, 3, 4, 5, 6, 7. So I'm going to do 360 divided by 7. What did you guys come up with 360 divided by 7? 51.4. Good. Again, had to do some rounding there. Just says 1/10, so 1 decimal place. Number 8, same process. Here we have our nice traditional stop sign octagon, but just in case I'll count, and yes, indeed, does have 8 sides. So we're doing 360 divided by 8. A nice whole number, 45 degrees. 45 degrees. So those questions are not particularly difficult. They will not be worth as many points as some of the other questions. But there are lots of them, so having some nice, easy questions should allow us all to do well. But again, I've said it many times, count carefully. Had someone miss a whole bunch of these questions, and I could see that he didn't mark any of the sides, he just eyeballed it. And then almost all of them he had counted incorrectly. So, didn't go well. Our strategy here should be that, in this case, they are both quadrilaterals. But no matter how many sides it had, we should count the number of sides, find out the total number of degrees that would be inside. In this case, there are 4 sides, so 6 minus 2. That's why I don't usually make a video while I'm teaching, because I say things that aren't right. 4 minus 2 times 180. And you may just have memorized that if it's 4 sides, it's got to be 360. So 2 times 180, the total needs to be 360. So whether you write yourself a little equation that you write x plus 65 plus 115 plus 95 equal 360, or maybe you just grab your calculator and do 360 minus 95 minus 115 minus 65. We should still come out to the same place. For those of you who like to simply grab your calculator, if things go well and you type everything in correctly, wonderful. But know that if you don't write anything down except a number, and then maybe you hit the wrong button on the calculator, then I can't give you any points for that question. Okay? So you'll have plenty of time. You could take the time to write down what it is you're typing in so I can at least see your process. Because if I just accidentally left out a number and then, got 185 instead, and just wrote that down, then I would just have to count it wrong. And then number 10 is very much the same as number 9. It's again 4 sides, so we know it has to add up to 360. So I've got some mystery angle. You could call it X, you could call it V, whatever. And the other 3 angles add up to equal 360. So you could either total them first and then subtract, or subtract each of those from 360, just one after the other. How much did you guys come up with? 88. Me too. Good. So 88 degrees. What if in one of these spots there was not a number, there was a little box? Then we know that that's 90, okay? So if you see not a number in one of the angles, but instead the little box showing perpendicular, you do need to include the 90 for that. Kind of makes it a little bit easier, but just make sure that that doesn't throw anybody off. For number 11, we have our parallelogram. We are told that QT is equal to 8x minus 11. So I'm going to put that on my graph, QT 8x minus 11. And then we are told that Tn is 5x plus 4. We are asked to find Qn. But before we can find Qn, we need to find x. So what is the relationship between Qt and Tn? They're the same. They're equal. So remember that those diagonals, since it's a parallelogram, bisect each other, which means when they cross, they split it into equal parts. So since they're equal, that is how we're going to make our equation. So then we have a chance to use our outstanding algebra. I think I might have just touched the bottom and that's what did it. All right. So then you're going to solve that equation, showing as much work as you might find necessary, which may be at this point in your algebra career, maybe you don't need to show quite as much work as I am currently showing, but so that I don't lose anyone. So remove that variable, got your two-step equation. I've got 3x equals 15. So x is 5. I'm so excited to have solved my equation. Am I finished? No. Aw, dang. All right, so what am I going to do next? Okay, so I'm going to find Qn. Well, but nothing tells me what Qn equals. So I can put the x in. Which one should I put it in? Whichever one you want, right? Because they're equal. I heard someone say 5x plus. That just seemed easier, right? So I'm going to do the 5x plus 4. So I'm doing 5 times 5 plus 4. So that gives me 29. Now that 29 is Tn, right? Is that what we're looking for? No. Ah, yes. So then Qn, I need to do 29 times 2. Qn would be 58. Now, if someone wanted, they could plug into 8x minus 11 also, and then add those two together. I think one plug in and multiply by 2 is the easy way. If you wanted to double check your work, then yes, plugging it into both to make sure that both of them give you 29 would be a good idea. But of course, paying attention to what it is we're being asked so that we don't do, only part of the problem is a good plan. All right, let's make this a little bit smaller so it all fits on the screen. All right, so here, first thing, is that our points that I did not have written on here when I made the copy are 0, 6, 4, 7, 3, 2, and -1, 1. When we worked problems like these in class, we did not have a graph. You do need to plot the points. If you want to go back and use the points to use distance formula or slope formula, you can. That's why I left you so much space on the page. But I'm going to show you what I personally would do and think is the easiest. So if first I plot my points, be careful with the 0. 0, 6 is going to be on that y-axis. So 1, 2, 3, 4, 5, 6. There is M. P is 4, 7. 1, 2, 3, 4, and 7 would be up here. Z is 3, 2. There's Z. And negative 1, 1. Negative 1, 1. Is that Q? Yeah, Q. Oh, I'm down 1. Say thank you. I would have started doing my slope and it would have been wrong. Negative 1, 1, not negative 1, 2. Thank you. I don't know why I put a parenthesis around that. There we go. And then if I connect those, now, if you connect your points and it doesn't even look like it's close to a parallelogram, then check your points, because it should be at least close enough that you're like, maybe it could be. You can find distance formula using the points. Remember, that was our big subtract. We can do the whole subtract the x's, square it, subtract the y's, square it, add them together, take the square root, yada, yada, yada. You could do that. That would be theorem 1. You could find that MP and QZ are the same, and the distance between MQ and PZ should be the same. So, yes, you are welcome to do that. I think with the picture, theorem 2, where we prove that they are parallel, is our easier choice. So, to prove that they are parallel, we want to focus on the slope. So if I can find my slopes, and remember that slope, I can use my points and subtract my y's and subtract my x's, but if I have a graph, I can just count rise over run from left to right. So if I want to know from M to P, so my slope for MP would be up 1 over 4, right? I'm just counting. Up 1 over 4. What about my slope for QZ? Up 1 over 4. And then I need to look at my MQ. And you've got some room. You could write this wherever, but I'm just writing it where we can see it. So if I'm going to go left to right, I'm really going more from Q to M. You could write it in either order, though. So it's going up 1 or up 5. 1, 2, 3, 4, 5, right? Up 5 and over 1. And if I go from Z to P, up 5 and over 1. Do you see what I've done? So I've shown the slope. You can, if you want to use this and you can. If you want to actually find the slopes using the points, we should still get the same answers. If it looks like, I think it looks like it is, and then your numbers aren't coming up right, double check yourself. So you might be thinking, well, what do I have to show you? Well, if you're using the slope, you should be showing me that you found the slope. If you're doing distance formula, Max had worked it out. He had distance. So he had like square root of something, and he could show me 2 sides were the same and the other 2 sides were the same. Okay? So if you really think you want to do distance formula and you want me to remind you or show you that before if you don't remember and you're not confident with how to use that, then I would probably use the slope and just count the rise over the run. You're not looking for all four of them to be the same, of course, just the opposite pairs of sides. And then on this last page, we have some area, not big composite figures. After yesterday, some of you might have been like, whew, I was wondering what she might put on there. I could have selected some big thing, but we'll try to keep things pretty simple. So our area for a parallelogram, remember that was half, or you could use 0.5 there. We add the bases together, multiply by the height. You could write the height at the beginning instead. It is important that you know which two are the bases. They are the two that are parallel. So here I'm going to do 0.5 for my half. I'm adding my 5.5 and 10.9. And then I am multiplying by 8. By the way, you could use parentheses and type all that into the calculator. I would encourage you to at least show me how you set it up so that if anything goes wrong, I can see, what you started with. 65.6. Yes, good, me too. 65.6. And please give it a label. So this is feet, so it's area, so it's square feet. So 65.6 square feet. What kind of shape is number 15? A triangle. And what is our area formula for a triangle? Half of the base times the height. Or you might just say 0.5 base times height. We got lots of decimals here. Typically the one that we see kind of across the bottom is what we think of as the base. But if you put them in the opposite place because they're all getting multiplied, it really doesn't matter. As opposed to if I got the base and the height messed up in my trapezoid, I would get a wrong answer. So we should be doing 0.5 or 1/2 times 2.8 times 1.6. So we get a very small number. And in this section, it didn't say anything about rounding. So I went ahead and kept this as 2.24 inches squared. Because we are rounding to the nearest tenth on so many other problems, if you had rounded that to 2.2, I would probably not mark it wrong. Okay. And then the next couple questions are a little different than anything we did on our assignment. But they are using the formula, the same formulas that we've used, but now we know the area, and we're going to use the equation to find a missing part. I will not give you one of these that is a trapezoid. That can get a little more complicated. These should be pretty straightforward. It's going to be important. I think it's important. I think it'll be helpful for you if you write down the formula first. So if I write down, it's a triangle, so area equals 0.5 times the base times the height. Well, here I know the area. So 28.1 goes here. 0.5. The base is the 8.4. And then we don't know height. So we're going to multiply these two together. So 28.1 equal 0.5 times 8.4, 4.2 times the height. And then what should we be doing? Well, it's not being added though. It's not 4.2 plus h, it's 4.2 times. So we should divide. We should divide. Because what are we normally doing if we knew the base and height? We would be multiplying. So we're doing 28.1 divided by 4.2, which turns out to be pretty messy, right? I got like 6.69, so I'll say 6.7. I'm not really thrilled with that being that messy. And then it's just one of the sides. It's just the height, so it's not feet squared, it's just feet. Number 17 is a parallelogram. So it is a parallelogram. The area is just the base times the height. So 29.3 is equal to something times 3.9. So again, we would be multiplying if we knew base and height, so we need to divide to solve. Because we want to get that b by itself. Again, pretty messy. I got 7.51, etc., so I'm going to say 7.5. And again, this was in square miles, or I see my height was in miles, so this is in miles. So it's kind of like we're solving an equation. It's not kind of like, we are. We're solving a little equation to find the missing part. And then 20 and 21, we are back to angles. And you might remember, you might not, but in a parallelogram, consecutive angles, which means right next to each other, or you could call them adjacent, are supplementary. So they add up to 180. So if the two angles are next to each other, you're going to add them to equal 180. If they are opposite of each other, like across from each other, then they will be equal. They are congruent. So in this case, number 20, these two are next to each other. They're consecutive angles, so they're going to add up to be 180. You could set up your equation like this, or you could subtract from 180 and find out how much is left for the 7x plus 3. Since I already wrote this, I'm going to go on and do it the way I have it set up. And then here, now I would subtract. Someone is calling me. And then when we divide, we get x is 6. And it just says solve for x. So there's not something else to do. The other way we could have done that is you could do 180 subtract 135, get 45. This angle is 45, and then just do 7x plus 3 is 45. We still get 6. So your choice, you could figure out the number for that angle and then solve a smaller equation. And then 21, are they consecutive or are they opposite? They are opposite. And also we can kind of see like they're both obtuse, right? Compared to one being obtuse and one being acute. So since they're opposite, we should be setting them equal to one another. And then we just have a nice two-step equation. So I have 116x is 116. And when we divide, x is 1. Nice little old 1. Right, so your quiz will be very similar, same number of questions. You might have like more triangles, or there were no circles on the review, so there will be no circles as far as the area. Yeah, you should feel like everything looks, there should be no surprises from the review to the quiz.